So I wanted to make a quick video showing you a few things in R, specifically R Commander. So we'll be using R Commander in class to run stats, to do descriptive inferential stats, and to make some nice graphs. So to get started, we will open R, move that where you can see it. I clicked on the icon and R opened, and next we need to open R Commander. If you've already installed R Commander, it will be in Package Manager. The windows keep going to the screen. I'm not recording. Okay, so we will find R Commander. RMCDR. It is R Commander without vowels or repeated letters. So here it is, and I'll click it. If you don't see R Commander in the list, then you simply need to install it from the CRAN, the download site. So I'll close this and show how to do that. In Packages and Data, instead of Manager, we will go to Installer. If you have not set a default CRAN, just find one in the first listing. It will list several different countries and different regions within each country. Just pick one from the United States and you can use the binary form. But once you have selected a default CRAN, you can click Save this as my default. I always use the one in Tennessee. It hasn't done me wrong yet. Okay, so I will search for R Commander in this package search text field. So I'll start typing RCMDR. That is RCMDR. Click Get List. And it is the first thing on the list. So I'll click R Commander, and this is important. If you're first installing this, for the install location, you can store it in the R framework, that's fine. Make sure you click this box, Install Dependencies, before you tell R to install R Commander. So by clicking this, once you try opening R Commander, it will automatically download all of the additional packages that are needed. So you would click Install Selected and then close this, and you would see a lot of stuff going on in R, all the syntax where it's downloading from the CRAN site. There will be several blue lines that fill, like 0 to 100% full, and you should see downloaded successfully. Successfully. Once everything is installed and it stops, when it's done installing, you will see the red cursor, that greater than sign, which indicates that R is done processing your previous request. So once it's been installed, you can go to Package Manager, scroll down and find R Commander. I actually saw it there, and load it. So I'm waiting right now for it to load, and it should display the graphical user interface, the GUI, R Commander. Alright, so this is R Commander, and a few things about it. There are 3 different areas. We have the script. This is where the syntax will appear, but you don't have to write any syntax. You can use the drop-down menus to perform all of the operations. The output, if you are calling descriptive statistics, all of the resulting tables and summaries will be displayed in the output right here. And you have a nice messages box that will tell you if something goes wrong. Hopefully it will stay green. It turns red if there was an error. And it explains what it was. And you can always use the R help tool, question Commander, and get additional feedback if you have an error. Okay, a few more things. So we have the menu trees at the very top. You can, well, this isn't very useful unless you have a data set to kick around with. So you can create a new data set, change the title to whatever you want. And you have the option of entering data manually. So you can add rows, columns, depending on how large you want the data set to be. But I never fool with that. I prefer to, I'm just discarding the edits. I like to just import data sets from Excel, like what we'll be doing with the package player results. So I will go to Data. Oh, and by the way, whenever you cannot use one of the tools, it will be displayed in gray text. The black text means that you can use this. So R prevents you from applying the wrong summary or the wrong analysis to your data set. All right, so to import data, I'll go to Data, obviously import data, and I can import many different file types. Text files like CSV, you can import from SPSS, Minitab, but I'll select from Excel file. I'll give it a name, R Commander Demo, and the defaults are fine. We do want R Commander to treat the first row as the list of column titles. So these are the variable names. We don't want row names going left to right. And convert character data to factors. Any text will automatically be treated as a factor. So if you have congruent versus incongruent trials, that will automatically become a factor, which is an independent variable. The level of the IV, I guess. Okay. I have a name, and don't use any spaces or special characters. It will not work if you have special characters or spaces. You can separate words using a capital letter or a period. Something like this. R Commander period example. I'll say okay, enough with that. And I will load an example data set. So I'm just navigating to actually our shared folder and R Commander presentation package. I have saved this example data set, and it's an XLS Excel file. Those are the file types when you're saving. It says Microsoft Excel, Windows 97 to 2003. When you use this type of Excel sheet, it will save any formulas or anything fancy you've done. It will still read into R. All right, so I'll open it, and voila. Now, in the dataset menu, I have the loaded data set. I also have many others that I've loaded in the past. Okay, so you can toggle between different data sets just by left-clicking once on this menu and finding the appropriate one. All right, you can view the data set. Let me move that to where you can see it. I'm 2 screens over. Aha. So you can quickly just look at the data set to make sure that it loaded properly. And it looks like this one did. You can manually edit the data set by clicking Edit Data Sets, and you can change things, but I'm not going to change anything. When you close, it will ask you, do you want to discard the edits? Yes, I'm not changing anything. Okay, so we have a data set. To start off with, I wanted to show you how to do a few things. So we can just get a quick summary of all of the variables in our data set. In fact, let's see which variables we have. In the data menu, I will go down to active data set and look for variables in active data set. And this will provide a list of all the variables. So This is a list of each column header, so row 1 of the spreadsheet. Okay, that looks good. Now let's summarize all of these variables. So in statistics, in this menu, in the summaries, descriptive summaries, I can first try doing active data set. This will provide a summary of all variables in the current data set. And you get a message, there are 11 variables. Do you want to proceed? Yes. Okay, so I have a basic summary of all of the variables. If they are factors, it simply provides a frequency count. So these are all of the students, and it doesn't list them all because there are 130. But the frequency of each student, and it looks like they are appropriate. And now we have the search type. We have conjunction or feature trials. Set sizes, 1, 15, 35. So these are the set sizes in the visual search experiment that I conducted with my class. And that's kind of confusing when we have them out of order. So first thing I can show you is how to reorder variables. But moving on from that, we'll go to that next. For the continuous data or the numeric data, we have average reaction time. We have measures of central tendency, quartiles, so on and so forth. So the average reaction time is 970 milliseconds. Okay. We don't really need this date and time, so I'll also show you how to get rid of that variable. All right, manage variables in active data set. We can do a number of things here. We can recode, we can calculate new variables. But first I want to reorder factor levels. So I'll select that and pick one factor. I want to reorder the set size. And I just want to replace set size. Actually, in this case, in the future, I plan to use set size to run a correlation. So if I reorder a factor level and do that with set size, it will convert it to a factor. So I am going to say set size factor. So I'll provide a name, set period size period factor, and select OK. So now it reads in all of the levels. Here are the old levels. What order do you want them in? That one's right. I'm going to go 1, 5, 15, 30. So 1, 3, 4, and 2. So this will be the new order that it is printed in, or that it displays. Okay, so if I complete that again, if I redo the active data set summary, now we see there are 12 variables. And in fact, when I made the new variable, you can see right here, the message said, now you have the same number of rows with an extra column, because I added that new variable to the very end of the data set. Okay, so I want to summarize them again. And look, now the set size is in order. 1, 15, I went too far up. Oh, here it is, set size factor, 1, 5, 15, 30. So those are in order. All right, let's remove the date time variable, because that's not very helpful. Active data set, remove, no. Manage variables. Delete variables from dataset. Scroll down until I see date time. Okay. And it will give you, are you sure you want to delete this? Yes, I'm sure. Thank you. Okay, so now we're back to 11 columns because we deleted one and added one. All right, stats. So the summaries, you can summarize all of the variables. That's helpful, but you can also select individual variables. or specify with more detail what you want in your summary. So I might not want the interquartile range. I may just want the mean and standard deviation. I want to generate a concise table. I'll deselect quantiles too. So there are checkboxes, you just check on check as you need. And what variables do I want to summarize? What do I want the mean and standard deviation for? Well, I'll do reaction time. If you want to select multiple variables, you need to hold the Command in Mac or Control in Windows. Hold that button and select the variables that you are interested in. I'll do these two, and I'll summarize it by group. I'll summarize by factor, by set size. Okay, so I am done. Let's see what she wrote. Okay, variable accuracy. So I have the mean for accuracy for all 4 set sizes. It looks like it does differ a little bit, not much, but yeah, the reaction time definitely varies. So just a simple little table, and several more things you can do. You can make a contingency table. If you want to create a frequency table, you can do two-way table, and you can compare sets, look at set size, and I want to know the number of trials that I have. Let's see, for search type and target condition. So I want to see what combination I have of whether the target was alone or if there were multiple targets, and whether the trial was conjunction or whatever the other condition was. So there are 2 search types, conjunction versus something else, and 1 or more targets. So I'll say okay. All right, so the target was either present or absent, and there are 23 conjunction when it was present, 23 when it's absent, and same thing for feature. So that's a quick way to make a contingency table. And I mentioned wanting to do a correlation. So I think that accuracy, well, reaction time should be correlated with the set size. So this is a visual search task, and there are lots of pluses and minuses on the screen. It could be up to 30, anywhere from 5 to 30. And one of those is the target that they are trying to identify, and the response time should increase with increased set sizes. So let's see if that's true. We have average reaction time, and okay, so I do not see the set size, which means it was treated as a factor. But we can fix that, and this is another learning moment. I will go to Manage Variables in Active Data Set and Compute New Variable. The new variable name will be set size. See, they're both factors, so we need a numeric set size. So set period size period numeric. And this is something that you just have to know from R, but hey, I'm telling you now. To convert something from a factor to a numeric variable, the function is as period numeric, and you just place the variable in parentheses. So I'm going to select set size factor. If I double click it, it will automatically type it in. I could have typed that manually, but I'm lazy. Okay, so I'll close parentheses. As numeric, so make this variable numeric, and then okay. Okay, now I've added a column, And that means I have a new variable that is set size and it's numeric. So back to stats, summaries, correlation test. So now I have the set size numeric. I'll hold command so that I can select average reaction time. Okay, I'll do Pearson and two-sided. I'm not sure where it's going to go. I kind of know, but all right, so let's see. We have the correlation, and it's not significant. The coefficient is 0.02, so that's not a very strong, not a very steep slope by any means. But it should differ, and I know this just from looking at this type of data set before. So it could be that the two, let's go up to our variable levels, conjunction and feature searches are very different types of conditions. So right now, that correlation is grouping all of these together, but I can subset the data set to see if this search type is important. And actually, just to show that, I will do a multi-way ANOVA for set size and search type for reaction time. Okay. That was my phone ringing, sorry. Yeah, so it looks like the search type was significant, so we're justified in subsetting the data set. You don't have to run an analysis to justify it, but I like to. Okay, so data, we are subsetting the full data set for both of the conditions, search types, either feature or conjunction. An active data set, subset active data set, subset expression. So I will be splitting it by search type. If I can find it there. If I double click this, well, it doesn't double click. I don't need to select anything. This is selected, so I'm taking everything in the data set for the rows that meet this condition. So the subset expression is search type, search period. This is case sensitive, so you have to type it correctly. I want everything, every row in which search type equals, and this is a weird thing, you have to use two equal signs. So search type equals, and this is whether it's feature or conjunction, that is currently a factor, so I need to put it all factors in quotes. Open quote, feature, close quote. And I'll say name for new data sets. I don't want to overwrite the full data set, so I will say R Commander demo feature only. Okay. All right, so now the data set has 160 rows and only 12 columns. So 160 from 206. All right, and now we can see the data set. It automatically opens the new data set. So feature only. I will go back and subset it to include conjunction only. R Commander example, that's the original data set. Okay, so now I'm back to the full data set with 206 rows. Data, active data set, and if I can find it, yeah, subset active data set. I'm going to do the same thing. It was, let me make sure I'm typing the name right. Target search type. Search period TYPE. equals equals. Sorry, I'm losing track. All right, conjunction. And I'll save this again. Conjunction only. Okay, so now I have the new data set, and you can view it. I'm moving it where you can see it. So search type, conjunction. It is only conjunction. So now I have only 46 rows, 12 columns. So for conjunction, let's make a quick scatter plot to see how close the correlation is. And actually, I'm going to go back to the full data set. R Commander example, okay. That's the original data set with both search types. And I want to make a scatter plot for, on the x-axis, I want the set size numeric. On the y-axis, accuracy, or reaction time. Average reaction time, set size. I'll plot by groups and split it according to the search type. In options, so I have a group, search type, X variable, Y variable. In options, the tab beside data, I want to include a regression line, a least squares fit regression line. Also, just to get fancy, I will include box plots in the margins. And the variables are properly named, so I don't actually need to necessarily change the labels of the X and Y axis. I'll say OK. And here is my graph. So conjunction reaction times are plotted with black data, and the red triangles are feature search type reaction times. So those two regression lines are very different from one another. So it made sense for us to subset the data sets and to look at any possible correlation between the set size and reaction time separately for each condition. Okay. So when this is all grouped together, the correlation was like right in the middle, you know? Let's go back to the subset of feature only. And then redo statistics, summaries, correlation test. Again, we're doing set size with reaction time. Holding command to select both. And OK. So this is not significant. This was the data set feature only. So we were only looking at the red. So yeah, that's not a very significant correlation. All right, let's look at what I think will be significant conjunction. All right, R Commander example, conjunction, stats, summaries, correlation test, average reaction time, and number of trials. Oh, not number of trials, set size numeric. Okay? And yes, this is a significant correlation, and the slope is pretty steep. It is a slope of 0.76. We can do another scatter plot with just this data. So on the x-axis, we should again use set size numeric and reaction time. Regression line, yes please. Wonder if I can get the equation on smooth line plot. Okay, so here we go. Legend position, let's just move it to the bottom right just because. Oh, there's not a legend because there's one group. Yeah, so the set size, that doesn't make sense. It's either 1 to 4. to look back at previous graphs, I can hold the command button and do left and right. Oh, so it's just, 1, 2, 3, 4, but we know those values are 5, 10, 15, and 30. So 1, 2, 3, 4. All right. A few more things. In stats, summaries, we have numeric summaries. You can just play around with these. I primarily tell students about active data sets and numeric summaries, especially numeric summaries, because you can specify your output. If you want to convert a numeric variable to a factor, you would do it by selecting this. And in this case, let's just, for the sake of an example, convert the numeric back to a factor. So you can either supply level names or use the number. Since this is 5, 10, 15, and 30, if we use numbers, it will just use the same value. But let's supply level names just to show you how to do this. And I don't want to write over that numeric variable, so I'll make another one. New copy set size. I'm trying not to take too much time with this. Okay, so numeric value, level name. So for the first one, hang on, let me look at the data set. Okay, so it's either 1, it's a lot of ones, but 5, 15, 30. So there are 1, 2, 3, 4. It doesn't vary a lot with hang on one second. Okay, so I'm back to the Archimander full data set. And there are a few more things that we can work on. Yeah, recoding or convert numeric variable to factor. Let's make sure. If I look at the data set, on the right I have set size numeric 31431. So I have 1 to 4 and 3. Let's go to the very top. Oh, set size factor, here it is. I know what I did. When I made the numeric version, I may have selected the incorrect variable. So data, manage variables, compute new variable. I will select the original set size, new variable name, new. All right, so when you convert something, a factor, into a numeric variable, it automatically codes it as the original coding variable from the factor. So if there are 4 variables, they are automatically given the value 1, 2, 3, then 4. And if you remember, the numbers were out of order. So the first thing that we did is reorder the set size. So when I earlier converted set size to a numeric value, numeric variable, it automatically assigned 1 and 2 and 3 and 4 to the variables. So looking here, the original set size factor 30 was converted to 3, 1 to 1, that didn't change, 5 was converted to 4, and 15 was converted to 2. So if that happens, this is actually a good way to show you how to recode variables. So let's take this new variable and convert it to the values that we actually want. So I'll go to Data, Manage Variables, Inactive Data Set, Recode Variables. I'll select new. That's just one I made up very quickly. And I will title it, I'm just going to write over the existing one, new. The default will be to make each new variable a factor, but we are trying to make it, this is numeric and we want to keep it that way. So I'm going to unselect that and then provide the recoding instructions. So we are converting the current 4, so 4 space equals space. The spaces don't matter, but it's easy to read. 4 should actually be the set size of 5. And that's all you do. All of the 4s will be converted to 5s. I'll hit return to the next line and continue with the list. 3 will be converted to 30. So you can see 3 now should be 30. 2 should actually be, let me find it, 15. And just for the sake of it, I'll say 1 equals 1. And I'm going to click OK, and it gives me a warning. It already exists. Do you want to replace it? Yes, that is why we're doing this. Okay, so now let's look at the data set. And look, I've converted them to the appropriate value. So now if I make a scatter plot, we'll do new on the X and reaction time on the Y. Plot by groups, search type. This is the full data set again. And oh, that was the wrong button. There we go. We have conjunction and feature. 5, 1, 5, 15, and 30. So the x-axis is correct. Earlier it was 1, 2, 3, and 4, which is a big problem because the set sizes differed. 1 was 1, but 30 was, I believe, coded 3, 15 was 2, and 4, the 4 value was actually the set size of 5. So you can see how this correlation is really confusing. But now it is correct. And that makes sense. Okay. So we have covered how to recode variables, compute new variables, rename variables. You can just rename them. If you want to, there are a few other things you can do. You can like bin numeric variables. So I could bin all of the reaction times. The default is find 3 bins using their, well, 3 is the default, which is good. Their algorithm will figure out how to bin them, and you can have a category like the fastest reaction time average, the middle, and the slowest reaction times. So we'll say bin reaction time. Okay, bin name. Number 1, slow, modest, fast. Okay. So we have, it's hard to see, slow, modest, and fast, and these are all categorized according to where R decided to split the reaction times. So average reaction time right here. Okay, so we could use that if we wanted to. All right, graphs. additional things, we can, if you have nominal or ordinal data, you can make bar graphs. The only variables that are available are those that are nominal or ordinal. Plot by groups, all of those functions are available. In graphs, we have scatter plots, I've shown you that. Plot of means, this can be helpful. So let's do search type and search size, set size and search type for average reaction time. Standard error will be the error bars. Okay, so those options are fine. Okay, here we go. We have, yeah, this is definitely a huge difference going 1, 15, 3, 5. I use set size, which is out of order again. That's the, I guess when I reordered it, I changed the name, so that's the original variable. So let's do that again with plot of means. Set size factor. There we go. So this is the one that I ordered correctly. That's why sometimes it's best to just write over the previous variables, because you may end up including the wrong one in a model. Kind of like, I might have done that already. Okay, graphs, histogram, plot by groups, all of these options. We can do search type, or let's do, yeah, search type. Set size is better. And reaction time. So now we have reaction time for all 4 set sizes and the frequency of each reaction time, frequency distributions. The really fancy, you can do a scatter plot matrix and select, let's say, reaction time. That should be related to accuracy, maybe. It's an empirical question. And set size, plot by groups, search type, options, density plots. Let's do box plots on the diagonal for this scatter plot matrix. Okay, so now we have this axis and this axis are accuracy. So this is, and the name here means that the vertical axes and the horizontal axes in any of these are reaction time. So set size is on the x-axis here, reaction time on the y-axis. So we have the same graph that we made earlier, but we have all possible comparisons. Not very useful in this case, but that's how to make that. So stats, means, we can do one-way ANOVA, set size, and reaction time. You can select pairwise comparisons. You can specify the name. I said no because I wanted to change this. In fact, right now I'm grouping both trial types. So I'm going to change the data set to feature only, stats one-way ANOVA, means one-way ANOVA, set size factor, and reaction time. So I will say ANOVA period set size and reaction time. Pairwise comparisons, I just like to go ahead and include them. Okay, here's my ANOVA table, and I have the 95% family-wise competence level. I tell, I'm joking here. I tell the undergrads, if this bar is outside of that dotted line, then that group varies significantly, or that comparison was significant. All right, so here's my table, and it's not significant. This is for feature only, but let's look at conjunction only. Stats, means, one-way ANOVA, set size, and reaction time. And this is for conjunction. This is definitely significant. So wow, whenever there's an ANOVA table, the p-value is listed, everything's labeled. The significance code is provided here. So 3 asterisks means p is less than 0.001. So that's pretty small probability that if you repeated this 100 times, you would find that size of a difference or larger if there were no effect of the independent variable. And the remainder of the table, it's all provided here. Okay, so means, independent samples, paired t-test. You'll need to have two separate columns of data to do a paired t-test, but you can run independent samples very easily. Okay, one thing about the ANOVAs. So I just ran the ANOVA for set size and reaction time for conjunction only. So my model that I named is right here. Since that is selected, I can go to the models menu and create a graph of the effects. So this is the effects plot, set size factor, okay? And there's just one variable, so it's similar to the plot of means. But let me show you, let's see if I still haven't. Okay, now let me go back to the two-way ANOVA. If you remember, I defined it earlier. We'll just go back to the full data set, our commander example, run multi-way ANOVA. Example, whatever, search type, and set size factor. Hold command to select 2, don't forget that, and reaction time. Okay, so in our full model, it looks like I went too far. Yeah, so our main effect of search type is significant, main effect of set size significant, and the interaction also significant. So now that I'm using the ANOVA I just created in models, graphs, I can create the effect plot and include both. It makes a nice plot showing splitting search type and feature for the independent variable according to the second. And for the dependent variable, split according to the levels of one independent variable and the second independent variable. All right, to save this, I want to show you the R Markdown. All right. This is the way of outputting your results. It's very helpful. You can just replace the main title. So let's say example with still leaving the quotes. Example demo R commander. And my name. The date is automatic, so we'll leave that alone. Any of these spaces here, you see the 3 dashes followed by blank space. Those separate all of the commands that I perform. So this is when I read in the data set, and so on and so forth. You don't need to get tangled with all the the syntax, but let's say I've scrolled down to the very bottom, and this is the model where I found the multi-way ANOVA. I might want to leave myself a note. So in this blank space, you can provide yourself comments. Note, this is the model I want to use in the paper. Yay. Other notes. Okay, so I have not interfered with the return characters, the dashes, or modified any of the syntax. Everything that I typed is within this white space. So now I will go to Generate Report, and I can generate a PDF, a Word document, so on and so forth. Before I do this, you should tell your students this. It's helpful if you set the working directory to some place that the students can find easily. So if you go to the R console, which is running R Commander, I'm clicking on the R console, and in Workspace, let's see, in Miscellaneous, I'm going to change the working directory and set it to, let's just say, my desktop. Open. Okay, so now I can go back in R Commander, and when the Markdown report is generated, it will do so in the desktop. It'll save it there. So I'll generate report. I like to use a Word document because it will wrap very long commands. So the text wrap includes everything. Sometimes the PDF can cut off some of the output. Okay, so I'm waiting for it. There we go. Here is our new Word document. I'll open this. And this is our Markdown document. So we have example, that's the title I provided with my name. The date was automatic. This is a copy of all the syntax, all of everything they did. So when you're grading, you can use this as a very easy to view output. So let's see. I provided a note. Well, everything is included. So all of the graphs will be retained here. You can copy this and paste it into your paper, whatever you need. All of these that I made. And I just want to scroll down, skip down to the note that I provided. So this is where the note is. Of course, you can, it's in a Word document now, you can annotate the crap out of it, but here is the note I provided and the table that I want to use. So if I know that in my Markdown document I use the word note followed by a colon, whenever I'm in this document I can search for note colon, and it will lead me to all of my notes. So that's easy. It's an easy way for the undergrads to quickly navigate this. Depending on how much analysis you do, this can be a very long list of results. If that's the only thing that I actually wanted, the very last table, I can highlight the information that I don't want to include and just delete it. So let's do that and generate it again. Waiting for it here. I may have broken it because this was opened and it's trying to provide a new name. Let me close that. And try again. Okay, so this is becoming a very long talk, but the Markdown, that's a very useful thing. I always have the students create one because it includes all of the graphs for them to include in their papers. And it's an easy thing, easy way to grade everything. All of the syntax is there, so they can't copy and paste from one another. It includes all of the information you need to make sure it was them doing the work. All right. So graphing, doing stats, descriptive and inferential, how to manipulate data, and once you've done an ANOVA model, you can create additional graphs here with the diagnostic plot or the effect plot. Let's see what that one does. Yeah, so here is a basic, which one was that? Diagnostic plot. So you can look at if it's a normal distribution, if it's violating your assumption of normality, which I think ANOVAs are much more robust than some people let on, and you can violate the assumption as long as you're not doing nomothetic research entirely. If you're doing idiographic research, you can violate that assumption. If you're just focusing on the individual and the variables that you were, if you want to know about the effect of variables on behavior or how variables interact, you can violate that assumption. Anyway, okay, a few things when you're closing. I encourage students to save all of their documents, all the files, but within the active data set, there is an option to save active data set. And you can specify where you would like to save it. So I'll just save this to our shared folder. You can spend all weekend kicking around with this and doing nothing else because this is so amazing. And when you go to close, it'll ask you to save, just save the stuff. Okay, and that's it. Thanks.